Hello everyone, my name is Finding Pepper and welcome back to the 4th episode of Terrain Generation. This episode is less about generation and more about doing things with the world we've generated. And today we'll be focusing on world updates, so that is making water flow and making sand fall, etc. We'll start by saving our project as a copy and naming it Episode 4. It's always a good idea to save as a copy, just in case something goes wrong and you want to go back to a previous version. Or you just like the previous version better, which, sometimes happens. Next, we're going to go over to my assets project, and there's a link to that in the description. And here we are. We are going to find the sprite called Terrain Gen 4. Now, in the costumes, we have got more of these crops for our water because, with water physics, we're going to want to have some other shapes our water can make. We also have a list here called tile data, and it has data for tiles, which we will need if we're going to be doing things with them. Right, and I'll explain that more in a moment. I'll just open up the backpack and drag the whole sprite into the backpack, like normal. Close it up, and head back to your project. Alright, open up the backpack and drag in the sprite. Now, this tile data list is for this sprite only, and we'll need our other sprites to be able to access it. I have Scratch add-ons, so I can simply click Convert to for all sprites. However, if you don't have Scratch add-ons, that's completely fine. You can show the tile data list and right-click and click Export. Now we can delete the tile data list and make a list for all sprites this time. Call it tile data. Show and import. Click Import and choose what you exported. It will probably by default go to a downloads folder somewhere. Now we also need to get our costumes from here into the tile sprite. So I'll just go down the list and drag each one in there. I'll make sure we got them all. We've got all we need out of the Terrain Gen 4 sprite, and we can just delete it. Now, as you can see, these water crops are a slightly different color than our sky. And your sky is going to be a different color than mine, and probably everybody else is doing this tutorial. So you'll just need to eyedropper the sky color using this tool, and then use the fill bucket and go down the list and fill them all in. It can be a little bit tedious, but alright, but that's done. Only took about 30 seconds, so no problem there. Now, we can get to coding, finally. Because we want our game and tiles to be updating all the time, forever, until we stop the game, it's generally a good idea to create a game loop, rather than having separate forever loops in each of our sprites like this. So, we'll create a new sprite, and call it something like main loop. So we'll get a when I receive start game, and then make a block called game loop. It's important that you do not click run without screen refresh. So we'll stick it there. And inside the game loop block, we'll have a forever loop. And in this forever loop, we will broadcast messages. First one will be move camera. Then the next one will be stamp tiles. So this means it'll move the camera before it stamps the tiles. And if you have other things that you might want to do later, like if you add a player, then you could add a new broadcast, the new message, move player, etc. In the stage where we have our camera movement, rather than having it in this forever loop, we'll have a when I receive move camera. And here we'll take off the forever loop and replace it with a when I receive stamp tiles. And make sure to keep this when I receive start game. So if we run that, that should work exactly the same way. We should still be able to move around our world and see everything just fine. Alright, it's time to talk about our tile data list. So up at the top here, I have what each property is. So property 1 is name, property 2 is shape, so that's like solid or liquid or air, and property 3 is whether it can float. So for example, a flower can't float or a torch can't float. We don't have torches yet, but that would be one example of that. Property 4 is must be above. For example, the top of a too tall flower must be above its bottom part, and a flower must be above grass. Property 5 is must be below, so that's just like must be above, but below. So the bottom of a too tall flower must be below the top half. Property 6 is affected by gravity, so that would be sand and gravel. Alright, let's start by making a block to find a certain property in that list. Find property number, and then number, text of tile at, and then input tile index. Run with that screen refresh. We'll make a variable temp for this sprite only, and the temp variable is essentially the return value of this function. If we had custom blocks with return values, that would be pretty cool, but we don't, so we're going to have to use variables for that. So we're going to set temp to item of tile data, and we'll get a plus, or times, and a minus. Now this slot on the left is going to be the tile. So we'll find item tile index of grid. We'll subtract 1 from it, and then multiply by, and here I'm going to make a new variable called data amount per tile for all sprites. So this is how many data points there are per tile, and for this there are 6. So this gets us to 1 before the first property of a certain tile. Now we can add the property number. That's that block done with. We should make sure to set our data amount per tile variable to 6 at the beginning of the game. Now we need to make a new block called update tiles. Run with that screen refresh. We're going to stick the block just below animate right here. We'll start by checking for tiles that can't float. So we'll find property number, and if we look at our list, tile data, that's property number 3 of tile at tile index or grid index. If temp equals in, so in means no, it can't float, then we will find property number 2, that's the shape of the tile at the tile below this one, so that's grid index -1. And if temp equals hash, that's a solid tile, then we can replace item grid index of grid with 2, that's AR, and then we will stop the script. So if it is floating and it can't float, then we'll just replace it with AR, get rid of it. Next we'll handle the must be above. So we'll find property number 4, and if temp is greater than the empty value, that means it must be above something. Let's take a look at our poppy here. See how it's formatted. It's formatted with an underscore and then a tile, then an underscore and then another tile. So the tiles, it can be above, separated by underscores with underscores at the end. So let's see if we can check that. We'll check if temp contains, and get some join blocks here, put underscores on the ends, and in the middle we'll put an item grid index -1 of grid. So, and then make sure to put this in a not. So if property number 4 of itself does not contain underscore and then the grid and then the tile below it, then that means it is not on a tile that it can be above. So we again will replace item grid index of grid with 2 and stop this script. Now duplicate this for property number 5, that is must be below, and we will check rather than grid index -1, we'll check grid index +1, because we want to make sure the tile above it is alright. And if it isn't, again we'll replace it with 2 air and stop the script. Next, for gravity, find property number 6, and if temp equals y, yes, it is affected by gravity. We'll check if the tile below it, that is grid index -1 of grid, we'll check if it's equal to 2 air. So if the tile below it is air, then it can fall. And then we will replace item grid index -1 of grid with item grid index of grid, which is its tile. And we will replace grid index of grid with air. Then again we can stop the script. I'd also like it to be able to fall into the water. So we'll get property number 2 of tile at grid index -1 and check with an or if either it's 2 or temp is equal to a tilde, which is the water tile. Now I can test that and try to find some floating sand for us to try out. Sadly, we can't test this other stuff that well. Okay, I made one mistake. I was checking here at property number 3, where we check if temp is in. I was checking if temp equals hash, that if it was solid, the tile below it, then it would disappear. We want to check if it's not solid, and then we're going to disappear. Sorry about that. So we should see our little grass. Desert. Oh, yep, there we go. Sand is falling. Now, as you saw there, it fell a bit fast for my liking. So, I'm going to do something to change that. In the main loop, we're going to create a new variable for all sprites called frames. Now, this will just increment each frame. We can make sure the sand only updates every other frame by checking around this whole thing. If frames mod 2 equals 0. So now it will fall half as fast. There we go. That fell at a better speed. Still fast, but not too fast. Alright, so next we will work on water physics. So we'll find property number 2. That's the tile shape. If temp is equal to tilde, then we will make a new block. Call it flow water. Run without screen refresh. As always, stick it in here, put the script after it, and begin to code it up. Now, to differentiate from the different stages of flowing water, I'm going to use different costumes, because we have all these here that aren't being really used for anything other than animation. So we can use them for our different stages. If we're going to do that, we need to make sure that they all animate the same way. So we'll check if item grid index of grid is greater than 8 in the animate block, and it's less than 40. Then we'll switch costume to 8 plus this, rather than costume number plus that. This way, all the tiles will animate exactly the same way. Alright, I'll add a little comment here that we can reference whenever we need to remember what tile's what. Tile 8 is the water source. Tile 9 will be our stage 8 water. So this is water that just came out of a water source or a flowing water column. Tile 10 is our height 7 water, and that's flowing to the right. And tile 11 is 6R. I'll just use the abbreviations for now. 12 is 5R. And then 17 will be 7 left, L. 18 is 6L. And so on. Wonderful. So we can begin to use this. Alright, so we're going to use our find property number, and we'll find property number 2 of tile at grid index -1. So that means that we're checking for the tile below the current one. Remember, this is running on every tile, each frame. So we're going to check if temp equals empty. That means it is not solid. Or temp equals tilde, so it is a liquid. Then we will replace item grid index -1 of grid with stage 8 water, that is number 9. So this will happen no matter what stage of water it is. Now, if this is not the case and it is some sort of solid, we'll check to the right of us. Find property 2 at grid index plus world height. We'll check if temp equals blank, so it is not solid. Then we need to make sure it is a tile that can be flown to the right. So if item grid index of grid is less than 10, so that means it's either the water source or stage 8 water, we'll simply replace the tile to the right of us, item grid index plus world height of grid, with 10. So that's the first water that's being flown to the right. If it is not less than 10, then we can still flow it. We just need to make sure it is less than 16, which is the last right flowing tile. Then we'll replace it with item grid index of grid plus 1. Now we'll find property number 2 of the one on the left. That's grid index minus world height. And here again we'll change this to a minus and this one to a minus. And instead of replacing it with 10, we'll replace it with 17, which is the first one to the left. And then here, rather than checking if it's less than 16, we need to check if it's greater than 16 and it is less than the last one, 23. If so, we can continue with this. Alright. Now, the last part of this block will be erasing any water that shouldn't be there. So we don't want to erase the water source. So if item grid index of grid is 8, then stop the script. Now if it isn't, if say it is 9, that is the flowing water, stage 8 water that is coming from above, then if there is no longer water from above, we should erase it. So we'll find property 2 of tile at grid index plus 1, tile above it. If it is not equal to water and a tilde, then we should erase it. Place item grid index of grid with 2. Now, if it's greater than 9 and less than 17, so that would be between 16 and 10. So, greater than 9 and less than 17. Now we'll find property at grid index minus grid height. Because if it's flowing to the right and there's no water source on the left, then it's going to go poof. So we'll replace it with 2. Then if it's greater than 16 and less than 24, so these 7 right here, then we'll check at grid index plus world height, and again do the same thing. Alright, that should be it for this block. I'm going to try it out. So we can see our water is flowing down here. And of course it's all blocky because we haven't used the crop yet. But it looks like it's behaving how we want it to, which is just lovely. Now it looks like the water on the very top isn't animating. That's of course because I checked if it was greater than 8 rather than greater than 7, so there we go, because greater than 8 does not include 8 itself, of course. Alright, so it's time to go into the crop water block. Now, rather than checking if it's 8, we'll find property number 2 of tile at grid index, and if temp equals tilde, then we will crop water. So we'll crop it for all of the water tiles. And in here, we'll put a if grid index of grid is 8 or 9. So those are the tiles that could be flowing downwards. Then, rather than checking if the tile above it is equal to its tile, we'll find property number 2 of the tile at grid index plus 1 and check if it is not equal to tilde. Then we can do the same thing, switch costume to water, surface, crop, and stamp. We can in fact move the stamp block to the very end, and in the else condition, this, I just made it an if else, we will stop this script. Now, if the tile is 10, that's the tallest one that's flowing to the right. Now here we'll check to the right of it, grid index plus world height. If temp equals tilde, we can switch it to the water R crop 7. Otherwise, we'll switch it to the water R crop steep. So if there's nothing to the right of it, if there's no water to the right of it, then it will be steeper. Here's the steep one, and here's the not steep one. If it's 11, then no matter what, we'll just switch it to number 6. 12 will be number 5. 13 will be number 4. 14 will be number 3. 15 will be number 2. And 16 will be number 1. Now, we're going to do a very similar thing for the other direction. Here, rather than checking if it's plus world height, we'll check minus world height. And it will be if it's tile 17, right? And we're going to switch it to the left crop, water L crop 7 or water L crop steep. And then go down the list, increasing the numbers. And then change these to left 6, 5, 4, 3, 2, and 1. Alright, moment of truth. Let's see how this looks. It's looking good so far. I am seeing, yup, this is looking very nice. Here, I'll make it big so you can see it better. And down here, you see we've got that nice steeper diagonal and then a shallower one there. And we got some more water going down over here too. So it does run into this other water, which can look a little bit strange. Oh, and I was just looking back at the flow water block, and I realized I put this inside here. So down at the bottom, these two if statements should be separate. Alright, there is actually a way to fix this. Right here, find property number 2 of tile at grid index plus world height. If the shape is empty, then we flow the water normally. Now, what happens if instead of being empty, it is a water tile? We'll need to replace this top one with an if-else, of course. Now, we do, of course, need to make sure that the tile is actually one of the water tiles that's flowing to the right. If it is greater than 9 and less than 16. Now, we check if item grid index plus world height of grid is greater than 16. And this is making sure that the one it's going to flow into is flowing the opposite direction. Now we can finally check if item grid index plus world height of grid minus 7 is greater than item grid index of grid. Now what this does is this makes sure that the height of the oppositely flowing water that it could flow into is lower than the height of the current water tile. And the reason we use a greater here is because as the height gets lower, the costume number gets bigger. Now we'll replace item grid index plus world height of grid with item grid index of grid plus 1. Now we should do the same thing for the water flowing to the left. So again, we'll convert this to an if-else. I have scratch add-ons so it makes it easy. And I'm going to duplicate the code from up here, and change this to minus. And of course we'll change the 7 to a plus. And we'll check for a different range of tiles. We'll check if grid index minus world height of grid is less than 17 instead, because we're checking for the water flowing right rather than the water flowing left. And we'll change this range of tiles it could be from 16 to 23. We're adding 7 here simply to compare the height of the water flowing the opposite direction, because there are 7 of those tiles, so if we add 7 to it, then that's what that height of water would be, but flowing the opposite direction. So if we run it, this should work just fine. We should also make sure when we say less than 17 that that is the flowing water and not the water source. So less than 17 and greater than 9. I do feel like this water is flowing a bit fast, so we can do the same thing as we did with the sand in the update tiles block. Do frames mod 2 equals 0. I'll actually make it frames mod 4 equals 0. Simply to make it just even a little bit slower. So yes, this is a much nicer speed. Alright, on the subject of world updates, let's add ourselves a day-night cycle. I'm going to go into the stage where we have our move camera script, and I'm also going to make a new variable and call it time. So we're going to set time each frame to time plus 2. The reason we're not changing time is so we can mod by 24,000. So there are 24,000 times in a day, and each frame we're increasing by 2. So if time is less than 12,000, that means it's the daytime. We'll set brightness effect to 0. Now if it's less than 13,000, then between 12,000 and 13,000 is when we're changing from day to night. and I'll do that in a moment. And then if time is less than 23,000, then we'll set it to -75 because that's the nighttime, and then in the else is when we're changing it back to daytime. Alright, so let's do these two, the transitions. So first I'll get a minus and put 75 in the right because we're looking to get to -75. Okay, in the left, okay, we'll get out a minus and 1,000 minus time, and then we're going to subtract 12,000, so the start of the transition is basically 0. We're going to subtract it from 1,000 because there are 1,000 frames between the day and the night. Then we'll divide it all by 13, which is approximately 1,000 divided by 75. Now the transition from night to day is similar, except we don't need to subtract it from 1,000 because we are increasing brightness effect rather than decreasing it. And we're going to subtract 23,000 rather than 12,000, of course. And here we are. So if we test it, nothing should happen. Although, we'll see time is increasing. I'm going to really beef this up, say 20, so we can see it in action. Alright, the sky is darkening. And here we go, it is the nighttime. Oh, and, of course, you'll notice that the water crops are not the sky color, so we'll need to change that, because we need them to follow the darkness rules as well. And, oh look, it's daytime as we're speaking, and the water looks normal again. We'll also get a when I receive start game and set time to 0. I'll drag this brightness into tiles and find the crop water custom block and stick this up at the top and make sure to put a set brightness effect to 0 at the beginning of each tile stamping, so the brightness change from the crop will not carry over to tiles. So let's find some water, and we can test this out. So as it gets darker, it should get darker in just a moment here, we should see that everything looks great. Now one last thing, now that our water can flow into caves and fill them up, I'd like it if the caves didn't overwrite water, because it's weird to just have a big hole in the middle of a lake. So we'll go into the Add Cave to Grid custom block. This is in the Generation sprite. And we have this whole list of tiles that caves cannot overwrite. We'll just add _8 to it. So, just like that. And now our caves should not overwrite our water. Yes, here we are. Here's a cave that is coming into this big lake, and it is not cutting a hole in the lake, which is just what we want to see. Now, I think we've made some great changes in this episode. The world definitely feels a lot more alive now that we've done that. It doesn't just feel like a static picture we're scrolling around. Now, before we end this episode, it might be a while before I make another one of these videos. I'd like to leave you with a few things you can think about if you'd like to continue working on this project. There are plenty of tutorials out there on how to add players, so that would be a pretty cool thing to do. I think it wouldn't be too difficult. Just follow some, standard scrolling platformer tutorials, and you should be able to code up some nice player movement. Now, if you'd like to go further, I have a Paper Minecraft project, which is shared, and it is started using this tutorial. So, and yet it also has a player, it has light flow, it has breaking and placing, crafting, mobs, chests, all sorts of awesome stuff. And you're welcome to look around in this project, and, you know, if there's something you want to add, say you want to add an inventory. Well, I've got an inventory sprite, and you can, you know, try to look over stuff and figure out what they do, and maybe you want to add them to your own project. And I definitely encourage you to do that. I've tried to make the variable names and things fairly descriptive, so hopefully you can understand what's going on. There will be a link to this project in the description. Anyways, I hope you have a great rest of your day. Well, I might not see you in another video very soon, because I plan to take a break from YouTube. I may see you in a future video. So yeah, have a great rest of your day, and goodbye.